Search for 10 or just
Yeah. Downstairs.
So this is
In the morning.
so today we're going to learn the last two techniques that you need to learn. Actually, there's one more. It's called the z substitution, but we'll just save that for multivariable calculus.
Okay.
Right, MVC people? The z substitution.
You guys lump.
let's look at this.
That's the most complicated one. So when you see an integral, look, I'm going to go through the thing. And by the way, in your book, they have like a flow chart that tells you like how to solve integrals. But it's easy. You look at an integral. The first thing you ask yourself, is it on the
It's a
list?
mess.
I'm
Don't do
gone.
it.
The second thing, can I make a u substitution to get it on the list? Third thing, can I do integration by parts? And if I can I do tabular? And then the last resort, well, for you guys, is either trig substitution, no, or integration by partial fractions. So let's take a look. Which one you want to do first? What do you think? Yeah, let's just do trig substitution. What if you saw this integral here?
Hey, she needs cough drops.
And let's make a condition here: x is greater than 0. No, you know what? I think we better put limits on this thing. Let's put limits.
Why?
You know what? We're gonna do it without limits first, and then we're gonna do it with limits, because you gotta see the difference, because I have to compress this, okay, now, this is not on the list. Cannot do u substitution. Like if there was an x on the top, could do u substitution, but cannot. Integration by parts.
Take a 4 out of the...
So, I'm going to tell you right now, anytime you see any of these expressions here, a squared plus x squared, a squared minus x squared, or x squared minus a squared, then that's a good candidate for trig substitution.
Oh, I already see it.
Okay, so what are the substitutions? You know what, I'm just going to tell you because it's going to make sense.
Wait, can I guess tangent inverse?
X
Oh,
equals
shucks.
a tangent theta. So, yeah, tangent. What about this one then? X is equal to a
Sine.
Hey, you guys are pretty good. And then
Yeah.
this one would be x equal a.
Secant.
Wow.
Oh!
And you know why you
Ramanuja!
no, you know why you guys can see it? Because you guys know your Pythagorean identities, that's why. And then the rest of you go, I just knew it.
I just knew it.
So when you see this problem and you go, okay, I'm gonna use a trig substitution, then you're gonna let x equal, following these things here, 2 tangent theta.
Theta.
Everybody see why a is 2 in this problem? Because
4.
that's 2 squared, that's why.
We.
Okay, now even if you don't understand why you're doing it,
Just
when
do
we
it.
do the problem, then you will see why that is. So now, once you find x, you need dx then. So what is dx? Now you gotta take the derivative of this. 2, what's the derivative of tan theta? Secant squared theta. And then you gotta put the d theta. I was walking around, some people not putting the d theta or the dx, you know, that's important. Because you gotta remember, it's actually dx over d theta, you're just multiplying the d theta on this side. Because otherwise, if you don't put it, they're not equal. They're not equal. That's like saying 1 equals 2.
Just put proportional.
Now, all you have to do is take these things and substitute it into this integral. What do I substitute for dx?
That.
2 secant squared theta d theta. What do I substitute for x squared, if this is x?
That.
4 tangent squared theta. See now, we transformed the integral from x's into thetas. Hopefully this one's going to be easier. Well, A, I can factor out a 4, and what's going to be left? 1 plus tangent squared
Hey, you
theta.
somebody!
Exactly, and that's why we make that substitution, because you have a trig identity that comes out over here. So what is the, let's just go to the next step, right? So we got integral 2 secant squared theta d theta. The denominator is going to be, now what's the square root of 4?
Secant theta.
2,
Secant.
and then 1 plus tangent squared theta is secant squared theta, right? What's the square root of secant squared theta? Absolute value of secant theta. However, I will give you a restriction, or you might have limits where you don't need to put the absolute value. So let's just say x is greater than 0. Then we don't even need to bother with the absolute value. The 2's cancel out. This secant cancels one of those, so you got the integral of secant theta to theta A. That's on the list. Natural log, absolute value, secant theta plus tangent theta
Plus
plus C. Box that, that's the answer.
-2.
Minus 3.
Oh, sure.
Because if your original problem is in terms of x, the final answer should be in terms of x. So, how do I change this back to x's?
Tan inverse x over 2.
You just go back to this substitution right there. Isn't that the same thing as saying tangent theta equals x over 2? And then you draw the triangle for it.
Oh.
Tangent theta is opposite over adjacent, and then you Pythagorize 4 plus x squared. Hey, that's the thing that's in there.
Oh my god. Are you
Okay, so now
serious?
watch this. Natural log, absolute value. Now you look at your triangle. What is secant theta? Well, cosine is adjacent over hypotenuse, so secant is
Hypotenuse.
hypotenuse over adjacent. So root 4 plus x squared over 2 plus, and then now you look at your triangle. What is tangent theta?
X over 2.
Opposite over adjacent, x over 2 plus c. And then you look at the back of the book, or if this is a multiple choice problem on the AP exam, I don't see this, Mr. Park. This is what they have. Absolute value of square root of 4 plus x squared plus x plus c. Now you box that, that's the answer.
Oh, you take a 1/2 no, I don't know.
What happened to the 2's?
Constant.
Hey!
Big.
Can you explain it more?
It went to the C.
Does everybody see why?
Yes.
Okay,
Oh, I
okay,
get it.
yeah, I skipped some steps here, but look. If you make a least common denominator, isn't that like root 4 plus x squared plus x all over 2 plus c?
Yeah.
And then if you use your properties of logarithms, that's the natural log of the absolute value of 4 plus x squared plus x minus natural log of absolute value of 2 plus c. But then isn't this just a constant? Natural log 2 is just a number, right?
Yeah.
So then you just incorporate it into this plus c, because a constant plus a constant is just a constant.
Say it first.
A constant plus a constant is a constant.
No, we're not saying that. So does it, yep, who? What?
Give her the chair, man.
Yoshida?
Is that one supposed to be an X?
What?
Is it?
I think it's missing
More than Blair.
It is an X!
Okay, sorry.
Just move your head a little bit, look. No, for real, like from here, it looks like a 1. But look, there,
Is it
now I see it, now I see the X. Come on, Yoshida.
Mr. Park, he's only in 9th grade. Come on. Yeah.
Okay, now, let me ask you this now. What would happen if, see, so this is no limits. This is an indefinite integral, so you have to write your answer in terms of x. So what would happen if you did have limits 0 to 2 then?
You would just plug
Now,
in
just like
tangent.
use substitution. If you make a substitution, the limits are going to change unless your last name is Ishihara. Because if your last name is Ishihara, you change it back to x's and then you go from 0 to 2. But we don't need to do that.
So dumb.
No, it's not. It's not dumb. It's just taking extra steps. So, what are the new limits over here on this theta integral?
Yeah.
How do you figure it out? Go back to your initial substitution. If I plug in 0 for x, because this is like from x equals 0 to x equals 2, correct?
Yep.
So if I plug in 0 for x, you get tan theta equals 0. So what's theta? 0. And then if I plug in 2 for x here, that's like saying tan theta equal 1. Pi over 4. These are your new limit. So when you get this answer over here, now you just simply go from 0 to pi over 4.
The C's cancel.
So don't go back to this and go 0 to 2. I mean, you can, that's correct, but that's just extra work. And then now let's go down here. Plug in the top number. Natural log,
Root 2.
absolute value of root 2 plus 1, the c's cancel out, minus plug in the bottom number, natural log, absolute value of 1 plus 0. Final answer, natural log, root 2 plus 1.
Box that.
Box that, that's the answer. Everybody see why?
Yes.
Because natural log 1 is 0, and this is a positive number, so you don't need the absolute value. Anyway, can you see that you don't get the same answer if you plug in 2 here?
Yeah.
Yes.
Sure?
Yeah.
Sure. Are you sure?
Yeah.
Okay. Okay, so this is an example of trig. Now we only have time for that one example, but what if you saw a minus sign here?
Ooh.
Then would you do a trig substitution?
A sine theta.
No, you wouldn't. You know why? Because if we just change that to 1, that's the sine inverse integral.
Alright.
You don't do trig substitution unless it's a last resort. So, oh, what if you saw this? Like I think you're gonna see this in tonight somewhere. What if you had that? Then that's a, can I do U substitution? No, then this one would be a trig substitution. And then, what if you saw this one? Then you would use this trig substitution.
Oh my
So
goodness.
don't worry. I think I gave you like 6 problems, 2 of each. Is
Oh.
anybody looking at those worksheets?
We're taking more.
Oh, it's in a pattern. So you know.
All right, and we only got 9 minutes. We're in trouble. The last technique is called partial fractions.
No.
Now in
Heavy
PCH last
side.
year, you guys demonstrated to me that you guys were very good at partial fractions. Okay, now
Right.
when do you use partial fractions? Okay, let's just do a really easy one to start with. How about dx over 4 minus x squared?
Easy.
Now, some of you are tempted to go, hey, wait, I can do a trig substitution. No, you can't. Right? Because, okay, let me ask somebody. Lamachane, what trig substitution would I use? It was just written up here.
I forgot.
1 out of 3 chance. Sine theta, tangent theta, or secant theta.
Secant.
No, it's sine.
Sine.
So yes, you can do a trig substitution, but take it from me. If you have a choice between doing partial fractions and trig substitution, partial fractions is easiest.
Sine because.
If you don't want to believe me, then do a trig substitution.
Hey, why is
Or-
it sine?
Because then you're going to get them,
Alright.
it's going to come out to 1 minus sine squared, which is cosine squared. Okay, anyway, so you guys remember, so we go on the side over here. How do I decompose this into partial fractions? So the first thing you have to do is you have to completely factor it. Does this sound familiar? Now, what would happen if the degree on the top is not smaller than the bottom? Like, for example, what would happen instead of x, 1 here, what if you had x squared or x cubed or something? Then you gotta divide first. In fact, Song just had a test on that today. He was asking me about that.
Song?
Yeah. Okay,
Roy
anyway,
song?
so this is the hardest part of the partial fractions. You gotta think. What fractions, when added together, will give you this?
Capital A.
Something over 2 plus x plus something over 2 minus x. Now, if you forgot how to set up these partial fractions, you know what you should do?
PCH.
Yeah, go to the PCH worksheets. Or, you sure we didn't do this
No, I
No.
don't.
in August?
I would have remembered the heavy side.
Yeah.
Okay, so, does everybody understand this? Because if you add these 2 fractions together, isn't that the least common denominator? So you just gotta figure out what these numbers are gonna be here. Now, you can guess and check,
Yeah.
Heavy side.
or we can just actually figure it out. So, first thing what you do, multiply both sides by the LCD. So you get 1 equals A times 2 minus x plus B times 2 plus x. Now, once you get to this stage, there's 2 ways of doing it.
Heavy
You
side.
can
Heavy
equate the
side.
coefficients,
No.
or you can do the heavy side.
Heavy side.
But you know what, I'm gonna do both ways, because sometimes on the harder problems, it's better to do a hybrid of the two, remember that?
Oh,
yeah, hybrid.
A hybrid?
Yeah.
Matrix.
So I'm gonna show you
Here right now.
both techniques. Okay, the first technique is called equating the coefficients.
That's too much work.
That's too many words. I mean letters. Okay, equating coefficients. So what you have to do is you gotta multiply it all out. 2a minus ax plus 2b plus bx. And then what you're gonna do is you're gonna put it like, okay, here are the 2 terms with x in it. What's the coefficient? Negative a plus b. Here are the 2 constants. Isn't that 2a plus 2b?
Yeah.
So if you equate the coefficients, negative a plus b gotta equal
0.
0, and 2a plus 2b gotta equal
1.
1. You guys understand? Because like on this side of the equation is like 0x plus 1. The coefficient of x on the left gotta equal to the coefficient of x on the right. The constant on the left gotta equal to the constant on the right. Solving these equations, you get? Now, if I were me, you know what I would do? I would divide by 2 and get a plus b equal a half. Then take these two equations, add them, what do you get?
2b.
2b equal a half, b equals a fourth. And then once I figure out b is a fourth, plug it back in, a is, if a plus b is a half, or negative a plus b is 0.
1/4.
1/4. They're both 1/4. This is called equating the coefficients.
Heavy side.
But you guys learned last year that Heaviside is more efficient when you have linear factors like this, yeah? So, here is the Heaviside method.
Heavy side.
Heaviside fell off the ladder.
What?
Yeah.
Heaviside is named after the mathematician Oliver Heaviside.
Off the ladder.
Wait, what comes before fall? What season?
Okay, so here's, no, this is, or was it Robert Heaviside, or was it Oliver Heaviside? I think it's in the book, right? You guys don't read the book. Okay, this is what, anyway, whoever Heaviside, he said, instead of doing this, why not just plug in numbers for x? So he said, what if I plug in 2 for x?
Oh.
Because it's gonna make this term 0, right? You're gonna get 1 equals 0 plus 4b, therefore b gotta equal 1/4. See how clever Heaviside was?
Guess and check.
Yoshida, I'm not understanding the joke.
Well, he actually fell off the ladder and died.
Why, you looked him up?
Yeah. Oh,
So why is that funny?
clever.
Cause he's heavy side.
Now, what's another good number to plug in for x?
-2.
-2, because it'll make this
Too
term 0.
much.
If I plug in -2 for x, that's 0. What is that? That's 4a, so you get 1 equals 4a, a is 1/4. So whether you do the Heaviside method, equating the coefficients, or a hybrid, you gotta get that. I don't care how you do it, you gotta do. Oh, so now we go back to this integral. So therefore, oh, what?
I thought we were done.
I
I was like,
Yeah.
PCH, yeah, I know.
Yeah, but now we gotta incorporate the
Box
calculus.
that, box A and B.
So this is equal to 1/4. I'm trying to look. 2 plus x.
I'm trying to look.
Plus 1/4. 2
You gotta
minus
be quiet, he's trying to look.
Okay, do you guys remember last year, you just stood up to there and you stopped, that was the end of the problem, but now we gotta actually do the integral. Okay, who's got the first one? Wong, first term, integrate.
It's always wrong.
Because I look on this side of the room, I see Wong.
It's always wrong.
Come on, man.
What?
Come on, man, this is a review.
Okay, I'll do the first one. Wong, you, natural log, absolute value 2 plus x.
Oh.
Okay.
Now I get it.
Wong, you got the second one.
1/4 plus 1/4 natural log, absolute value 2 minus x.
Oh, nice.
Why are you clapping at the wrong answer? Wait, you're clapping at the wrong answer. Yeah, it's minus 1/4. How come minus? Because the derivative of the box is negative 1. You gotta adjust it by putting the negative in the front.
I see something.
Wait, kick the board.
See, you guys clapping for the wrong Okay, we only got 1 minute left. Now listen, the hardest part of partial fractions is, what would happen, okay, let me just ask you this. What if there was a cube on that one? Let's just say, what if there was a cube?
You gotta put it 3
What you gotta
times.
do, no, watch. Then you gotta go
2 plus
b
x
over
squared.
2 plus x squared plus c over 2 plus x cubed plus d over 2 minus x. You have to know how to set up the problem. Now let me ask you this. What if this one was x squared plus 1?
Now it's the AX plus B.
Then now you gotta go
dx
dx plus e over x squared plus 1. Because it's an unfactorable quadratic.
It's too much.
You guys, come on. That's why we did this in PCH. So right at this moment, you would go, yeah,
Oh yeah.
I remembered it.
He used to be like, you're gonna need this in BC next time.
You thought I was lying.
Yeah.
Hey, Jonah, I got a joke for you. Humpty is like Humpty Dumpty. He had a great summer. I mean, he had a bad summer, but he had a great fall.
It's just the
Oh, you
average of
asked
the
what
first
season
and
came
second
before
quarter.
Yeah.
fall.
No.
The ice one.
No, bad dog.